and do a right tail test. Because we're going to reject if the sum is large. And so this is the way that we'll know if the sum is large. Okay? So your x, what do you think the x is?
That'd be your sum.
That would be your sum. And your degrees of freedom
1.
is 1. 1 degree of freedom. Okay? Step 6 says, which is compare to alpha. And therefore we reject or do not reject. If the p-value is low, you reject them all. Is my p-value low? Do
Lower than
do
0.5.
not reject. And step 7 is write the conclusion. What is the conclusion?
There is evidence to suggest.
There is evidence that, okay, remember, do not reject. There is not evidence. There is not evidence. You know, I don't even like that. The question is, first of all, let's answer this question. We said that admission rate was independent of gender, but we did not reject that. So therefore, we think this is true, right? Okay. It appears admit rate what? Is independent of gender. Okay, now in the question, to answer their question, is it fair to conclude discrimination?
No.
No, it does not appear that there is discrimination. Women, how does that make you feel?
Well, it doesn't tell me.
Yeah.
Just numbers. It's
Because
not
we looked at these numbers and we said, it looks like there's discrimination, and then we went through this whole thing and we said, no, there's not discrimination. What did Mark Twain once say? There are lies, damned lies, and statistics, right? Okay? And the statisticians don't like women. Is that what it is?
Yep.
Okay? I love women. I love my wife. And my mother. And my daughter. So, what's going on here? One time we said, yes, there's discrimination. One time we said there's no discrimination. Well, this is exactly what happened at the University of California at Berkeley. Women looked at admit rates and they said, we're not getting admitted. Okay? So, they said, okay, well, maybe it's the engineering department. Maybe the engineers are discriminating. Okay? So what we're going to do is we're going to copy these tables. And this time we're just going to look at the engineering department. So this is engineering. Okay? So they went to the engineering department and they said, okay, tell us your admission rate. So what they found was there were 30 men were admitted, 30 men were denied, which gives you an admission rate of 50%, right? There were 10 women who were admitted, 10 women who were denied, which gives you an admission rate of 50%. So what would you conclude about the engineering department? There's no discrimination going on. Well, if it's not the engineering department and we only have 2 schools, maybe it's the English department that are discriminating. So they said, okay, fine, we'll go to the English department. The English department found that 5 men were admitted, 15 were denied, and 10 women were admitted, 30 were denied, for an admission rate of 25%. What's going on? Same thing, okay? This is an example of what we call Simpson's paradox, which says that when you combining groups can lead to associations to reverse. Okay? So here's what happened at the University of California at Berkeley. What happened was they actually found that, now in this case, these are exactly even Steven. Neither department is discriminating. The problem is the engineering department has 80 people in it. The English department has 60 people in it. So the English department is smaller than the engineering department. So even though there's no discrimination going on in the English department, there's no discrimination going on in the engineering department, when you combine them together, because the engineering department is bigger than the English department, it appears that there's discrimination going on, when in fact there's no discrimination. Now here's what's funny about the University of California at Berkeley. There was discrimination going on, but it was in the opposite direction. Okay? The teaching department had lots of females in there. So they wanted to get more males in there. So they actually were discriminating against females because they wanted to beef up the males in the education department. In the engineering department, just the opposite. It was crowded with men. So they said, okay, fine, we're going to admit more women. And so, in fact, the women had a higher admission rate than the men did. And so what they found was, yes, there was discrimination going on, but it was in the opposite direction. Okay? In this case, we would say, oh, we had 11 and 29. You can say that in this case, okay, we've still got the same numbers of people. The women have the higher admission rate in both departments. But when you go back to here, it looks lower because the engineering department's bigger than the English department. And so that's an example of Simpson's paradox. Is not only is when you drill down, the associations are in the opposite direction that they started with. Okay? So, coming back to here, should you believe the admission rate or should you believe the chi-square test statistic? Chi-square test statistic is the better test. And we back it up by looking at Simpson's paradox.
So comparing the p-value, is that comparing it to the out of 0.05, and if it's lower than that, then you would reject it.
And you would reject.
That's correct.
Okay? Now, here's what I'd like to do. This is a good break point. So, do you want to do one more upstairs? Well, I'll pull one out of the book that we can do, and we're going to follow the 7 steps like we're supposed to. We'll do that upstairs. You guys can just watch me. We'll go a little bit faster. I will save this, and then we'll take our quiz upstairs.